In the given diagram, they are asking find the work done in moving a charge Q0 from A to B. Let's see how to do it. There's a line charge having charge density lambda and from it at a distance 2r, the arc is the path given to us whose center is this C. Now from here there is a point A and we are moving up to this point B. It's a line charge, it's infinite, so the lines are parallel perpendicular to the wire. So let's say we have reached from this point to this point, very small point we have reached. So this is the DL direction, and since electric field are always perpendicular to wire, this is the electric field and this is the DL direction. This is electric field. If I extend it, I can take this angle as theta, because it's better to always take acute angle as theta, never obtuse angle as theta. So the direction between electric field and displacement will be 180 minus theta. Now why I am doing so? Because work done is charge into potential difference, and potential difference I want to find out, it will have to be minus dot E dot dl, where dl is the path we are taking and electric field is this. That's what I'm finding out. If I solve it, I'll get E dl cos of the angle between the two, that is 180 minus theta, or I can write minus of E dl cos theta. Now this is the straight line I'm getting, and say at a distance, initially this is 2r and this is given as r, you can see that. So let's see how much it has moved. It has moved by this much in this direction. Okay, we can calculate it. Let's extend it this much, and we have a triangle like this. Okay, this is the triangle we are getting, where this is the angle theta. Okay, and this is how much? This is dl, this is also theta. Now this small distance in direction of this r can be written as dr. So we can write cos theta is equals to base dr upon hypotenuse dl. So dl cos theta is equals to dr. Okay, fine. So one more thing, that cos 180 minus theta is actually minus cos theta, so I can take a plus sign. And then later in the derivation I can remove dl cos theta by dr, and delta v I can get from 3r to 2r. That is what we are doing. Now potential difference, however, I can also take a mod sign, because I already know if it's a positive sign, test charge is always positive. It's a positive charge which is taken from this point to this point. So if a positive charge is taken towards the positive wire, we are increasing the potential difference. So here the potential will be higher and here potential will be lower. So later we can also write the signs. Anyways, we can continue for now. Electric field is 2k lambda by r dr from 3r to 2r. So 2k lambda log of 2 by 3. Okay, because I'm going from 3r to 2r, log of 2 by 3. That's what we are getting as a answer. Now we have to write ultimately potential difference, and whenever we are doing a work, see, we are doing the work because find the work done moving a charge. Also this positive charge cannot by itself move towards a positive line charge, so we have to do the work. And whenever you are doing the work, you always write final minus initial. That means we should always write VA minus, this is VB minus VA. Whenever you have to do work, external agency does the work, it is always final minus initial. So the answer would be Q0, and final minus initial means VB minus VA. We have calculated, but we are not aware of the sign. But I've told you, if a positive charge is coming closer to a positive charge configuration, the potential will increase. So VB is higher, we can directly write without fuss of any minus or plus thing. We don't have to think about it. Just write in a way that it is a plus. So we can write 2k lambda log of 3 by 2, and that's the answer to the question. Remember, this signs can be a lot of problem. By your common sense, you can finally ultimately give the sign of the answer, because closer you are to a positive charge, potential is higher. Okay, so that is the answer to the question.